Okay. So we were talking about the coefficient of performance. Yes? Okay.
Yes.
So we're talking about the coefficient of performance. It's like if you want an efficiency for the wind turbine. So how much I can extract over what is the maximum power I can maximum power that is present in the wind. Okay. So because I know that I have the upstream velocity, and for this upstream velocity crossing a certain section, I can say that the maximum power, the maximum energy that can be extracted is half rho u0 cube a1. All, if you want, all the physical explanations was already done in the course material. So once I calculate the extracted power, and I know the maximum energy, the maximum power present in the wind crossing my section, I can determine the coefficient of performance. And to make sure that you are not doing any calculation error, make sure that this coefficient of performance should be lower than what we call what, if you remember. From the course material, this should be lower than the Belt's limit. We have seen in the course material,
0.59.
yes, that the Belt's limit is 59%. So in case in calculation you got a fraction larger than 59, be sure that you have a calculation error and you should repeat your calculation. Okay, because always the coefficient of performance will be smaller than the Belt's limit. Okay, now in the last part, they want us to calculate the electrical power produced. How I calculate the electrical power? What should I use in this given to find the electrical power produced? I already calculated the power extracted by the turbine. And also I already calculated the maximum power, and the power that is in the wind. So P that is present in the wind. So already I use CP if you want here in general. Sometimes they give me the coefficient of performance and I have, let's say, P in the wind, I deduce P extracted. Here in this problem, they ask in different way. So they can play with inputs. If I give you CP, let's say, and instead of giving you, if I don't give you, for example, this velocity, and I give you CP, then you can deduce it. Okay, and I can play with variables. I can change inputs and tell you to get other outputs. So here they didn't give me the coefficient of performance, but they gave me everything needed to perform my calculation. They can, for example, give me CP, and then I have to get, let's say, another unknown. Maybe the area, maybe the velocity. So it depends how they construct the problem. Here I already know the extracted power from a wind turbine. So this is the power the wind turbine will give me. But actually, to transform it into electrical power, I still have losses.
Multiplied with the efficiency.
Yeah, exactly. Because I have losses due to different reasons. So I have first, I have the gearbox system that is used. Okay, so this gearbox system already I will have losses through it, and of 90%. I have 90% efficiency, so I have 10% losses at this level, and I have also the generator efficiency for electrical power production. So if I want to calculate at the end the total useful power, the electrical power is the extracted power from the turbine, P extracted, over the gearbox efficiency times, so gearbox GB if you want, and times efficiency of generator. Times, not divided, times. I multiply by N gearbox efficiency and I multiply by the generator efficiency. هلا إذا بدي استعمل the maximum power,
نضرب ب CP كمان.
Yeah, I multiply by CP. Okay. So, or I say P electric is P extracted times gearbox efficiency times generator efficiency, or I say P electrical is P maximum that P present in the wind, which is, if you want the power here, this power that we calculate as, this is the whole power present in the wind, which is equal to half rho U0 cube A1. So if I want to use this in the formula, I should first multiply by Cp to get P extracted. This is P extracted. And then from the extracted power, I will lose a part because I have efficiencies. So I have some losses. So then I multiply by N gearbox and N generator. And at the end, it's equivalent because P extracted is Cp times the whole power that I can take from wind. So this is the whole quantity of power present in my wind. But because I cannot extract it, I cannot extract the whole quantity because of the physics we explained in the course material, then I should just multiply by the coefficient of performance to get the actual amount that I am able to extract from my wind turbine. And this energy extracted from my wind turbine is not completely used at the end, because when I do the transformation from mechanical energy of rotation to electrical energy, I have losses. This is why they gave me the percentage of gearbox, the efficiency of my gearbox system and the efficiency of my generator. So if you want to compute the overall efficiency of the system, what is the overall efficiency of the system? And if I take
efficiencies
from,
مضروبين ببعض.
sorry, can you repeat?
The efficiencies multiplied together.
Yes, exactly. If I want to find the total efficiency of my system, so it's like I am dividing P final, the final power. P final is the electrical power extracted, okay, over P initial, the initial power, which is the amount of power present in wind, over power present in wind. So this will be equal to the coefficient of performance times the efficiency of the gearbox times the efficiency of the generator. Because through my transformation process, I have lost at several stages energy. First, when I extracted energy from wind through my turbine, then when I transformed my mechanical energy of rotation through the system of gearbox and generator. So this will be the overall efficiency of my system.
Doctor, can you repeat one thing?
Sorry?
When you finish, it's fine.
Sorry, I cannot hear you well.
I wanted you to repeat بس ال P electric وتحطيناه P extracted over the efficiencies. ما
Sure.
فهمتها.
Okay, I will, of course. Okay. Look, let us go from initial to final state, okay? You have wind crossing your system. This wind crossing your area here contains a certain power of wind, okay? You can say that the power of a flow over a certain area is calculated through half rho U0 cube A1, okay? So this was demonstrated in the course. So this is the total initial power that you have, but you are not able to use it completely. Why? So this is, if you want, this is, if you have efficiency 100% of your system, this is the power you will have. But your system is not 100% efficient. You have several sources of losses, okay? The first source of loss is when you pass your flow through your turbine, okay? You can demonstrate from the momentum analysis and kinetic energy approach that you will lose a certain part of this power. And how to compute how much you are losing? You have what we call the coefficient of performance. So first, P, if you want extracted, you will extract a certain amount of power from your, when your flow will go through your turbine. And we have that P extracted over P initial, which is P of wind. Sorry, 1 second. P extracted over P wind is equal to Cp. So this is the coefficient of performance. The coefficient of performance of the turbine will tell you what is the percentage of the power present in the wind that you can extract using your turbine. Okay, so already you can say that the ratio of P extracted over PW is Cp. Okay, now what will happen with this extracted power? The turbine will take this extracted power, and due to the rotational effect of the wind turbine, you will have the power transformed into like a rotational mechanical energy. Okay, this rotational mechanical energy will be transformed using the gearbox system and the generator into an electrical energy. And from efficiencies of these systems, gearbox and generator, you can say that P electrical over P extracted, okay, is equal to the efficiency of your system. Your turbine consists of several elements. It includes a gearbox system, and it includes a generator to transform to electrical power. But because these systems are not perfect, you have some losses. And this is why they gave you the efficiency of each of these systems, of the gearbox and of the generator. So P electric over P extracted is the product of efficiencies of systems of the wind turbine, which are the gearbox and the generator. Okay, now if I ask you what is the overall efficiency from the beginning to the end, then you should divide the final useful power, which is P electric, over the initial power present in wind, which is P wind. And you can decompose this ratio into two parts. You can say I will decompose it into P electric. Let me choose another color if you don't. Okay. P electric over P extracted times P extracted over P wind. So as you can see here, this is the multiplication of efficiencies, because P electric over P extracted is the efficiency of the systems of the turbine, which are the gearbox, and then after the gearbox you have the generator efficiency, times P extracted over PW, which is the efficiency of your turbine, if you want, because as the flow will go through the turbine, you will have some losses. So you have times, this is the coefficient of performance. So actually, the overall efficiency of the system is the product of efficiencies of systems that you are facing from the beginning to the end of your process. So because you have here several stages, first, flow should go through the section of the turbine. Already you have a certain efficiency, which is the coefficient of performance. Then after this power extracted by the turbine will go through a mechanical system, a gearbox, and then this after this it will go through a electrical system, which is the generator, and for each system you have some losses. So in overall, your overall efficiency is the product of the gearbox efficiency times the generator efficiency times the coefficient of performance of your turbine. Okay.
Okay, very clear. بس one more question. الexpressions تبع extracted power power of the wind ضروري نأجيك إياهم derived, or we can just put the overall equation?
لا, you should put the overall equation. Okay,
ما بنعملهم derive.
I don't want you to memorize. I don't want you to memorize it as it is. I want you to understand how we got it. Okay, because if my purpose is to memorize, I will give it for you. I don't want you to memorize anything. So you should understand what are the physics behind this equation. So just you should know that we are applying the momentum equation. We are applying the energetic approach to get these formulas. And once we get them, you should apply them. Okay. But as I told you, I know these relations are a little bit complex and they require some fluids knowledge. This is why I will not expect you to apply them for other scenarios, because it's complex. But for this case, because they were already explained, you are expected to know now how to get them. Okay. Any other
thank you.
question before we stop?
As Professor briefly said, Yana, we just multiply the power extracted by the coefficient of performance times the generator efficiency times the gearbox. And this is the power, electrical power,
لا
right?
لا
Or
لا لا إذا you multiply by CP كمان يعني it's times P wind الانيشال. If you don't multiply by CP then it's times P extract. Okay? يعني أنت إذا already you have P extracted from the wind turbine, you just multiply it by efficiency of the gearbox times efficiency of the generator to get P electric. However, if you start from the initial power present in the wind and you want to deduce the electrical power, then you should multiply by CP and NGB and NG.
okay.
Okay?
Thank you.
Professor
Yeah.
في two expression لpower extracted يعني في واحدة فيها U1 U0 U2
Yes,
وفي واحدة
exactly.
فيها U0
مظبوط.
U1
انت
بس.
بتستعمل صح. انت بتستعمل اللي معك عنها details. هون بهذا البروبلم عطوك U0 U1 so you use this one. Okay?
Yes.
وإذا معك U0 U2 you can use this one.
Okay.
Both are equivalent. Okay?
Yes, thank you.
بس عادة we know U0 U1. This is why this is most used. Okay, because we can measure the upstream and we know the velocity across the turbine. So in general, you know these two, not U0 and U2, not U2.
Okay.
هيدي الفورمولا P wind or P extracted?
نعم.
Extracted.
P extracted.
هيدي ال extracted
Okay.
power. Okay.
Professor, can you please send us this document?
Yes, sure. Sure, I will. I will post it for you, okay? Any other questions?
كم multiple choice بكرة؟ اختار.
Well, I will tell you now on the group. I don't remember. Okay.
The exam is an hour.
No, it's 1 hour and a half.
Okay, thank you.
Okay. Yalla, good luck for tomorrow. See you
Thank you.
tomorrow.
Thank you,
Bye
doctor.
bye. Bye bye.
Thank you.
Thank you. Bye.
Welcome.
Thank you, Professor.
Welcome. Bye bye.